Okay guys, welcome to Ravi Codecraft, and in today's tutorial we are going to solve another coding problem. So in yesterday class we have solved reversing an integer in C programming language. So if you didn't watch that tutorial, go back and watch that. It's a basic program problem, and today in today's class we are going to solve another coding problem. Let's take a look at the question first. So today's question will be to check whether a given number is an Armstrong number or not. So first, what is Armstrong number? So let's take example. Okay, wait. Let's take example. Let's take 370. Okay. So Armstrong number. What is Armstrong number? Armstrong number means if you take each digit and if you cube each digit like 3 cube, 7 cube and 0 and add each other and add each digit, it has to be equal to 370. So this sum will be equal to our actual number. Okay, so Armstrong number means sum of cube of each digit of number is equal to our actual number, then only we call it Armstrong number, otherwise it is not. So let's look here. What is 3 cube? 3 cube is 27, right? So we will write 27. And what is 7 cube? 7 cube is 343. Okay, and 0 will be 0. So if we add, it will be 370. So here sum is 370 and our actual number is 370. So this is Armstrong number. If you take another example like 123, here first cube of each digit. So 1 cube, 2 cube, 3 cube and sum. So it will be 1 plus 2 cube is 8, 3 cube is 27. So it will be 27 plus 8 is 35, 36. So this is not Armstrong number because our sum and our actual number is not equal. So this is not Armstrong number, but this is Armstrong number because our sum and our actual number is equal. So they are asking to write a program. They are asking us to write a program for this problem to check whether a number is Armstrong or not. So first I have written an algorithm here. Let's take a look at it. So first when we start, we have to declare variables. Actually we need number. This is original number, and if we are going to perform division operation here, so we will need remainder. Okay, and when we perform using remainder, we will get a number and we will assign it to result. Okay, so that's why we are taking 4 variables. So this is our actual number, this is our remainder in division, and this will be our cube value. Okay, 3 cube first, like that. Okay, this will be our number and our last result of our number will be result. Okay, so there are 4. We have to declare 4 variables, and first we have to take input, which is 370, and set original num equals to num, because we have to check, right? So at last we have to compare original number and our number after processing. So if they are equal, we will print it, this is Armstrong, otherwise this is not Armstrong. Okay, that's why we are storing num into original num initially. So after processing, our num will be either actual num or other num, which is actual our sum of cubes of our digits. So that's why we are taking original num, remainder and result. Okay, so first will be our num, and we are setting our num to original number, and we have to set result to 0, and we will stop the loop. Okay, in this loop we will check whether our number is 0 or not, because 0 cube equals to 0 only, right? Then why we need to process these steps, it will be actually memory consumption. So that's why we will check whether this is 0 or not. If it is 0, then we will give it as Armstrong number. If it is not 0, then we will perform our loop. Okay, so first we will check whether our number is 0 or not. If it is not 0, then we will go into loop and we will perform division operation. So first I will clear place here. Okay, we have a space now. So here if you look here, our number is 370. Let's take 370 and we are performing division operation by 10. So in yesterday class also we have performed this operation, right? Same exactly, we have taken number and we have divided it by 10. So 10 into 370, our remainder is 0. Okay, 37 times 370, so our remainder is 0. 0 into cube 0 only, and our result will be also 0. 0 plus 0 will be result. First our digit will be 0, and second time, this is first time we look through, and second time, why we are going to second time? Because our num is still not 0. We have to perform loop until our num is 0. So first we will look here, 10 into 37, 10 3 is 30, and 7 will be our remainder. So here 7 into 7 into 7 plus our result is 0, right? So 7 cube is what? 343 plus 0. Okay, so our result will be now 343, not 0. Okay, our result will be 343. Okay, now next we will perform third time, because still our number is not 0, so we have to perform another operation. 10 3 0 0 and actual remainder is 3. So if you look at our algorithm, here it is saying we have to cube our remainder. So 3 into 3 into 3 plus our result is 343. Okay, now 3 cubes are 27, 27 plus 343, our result will be 370. Okay, so now our number is 0, so we are stopping our loop and getting out of it. So we have performed our loop is finished now. So this line is also finished. Okay, and if you look here, if result equals to num, these 3 steps are finished. These 3 steps are our loop. So our loop is finished. Now we are at this line. If result equals to num means, if result equals to num, 370, our original num equals to 370 and our result equals to 370. So we have to print Armstrong number. Okay, so our number is Armstrong number. You understand it, right? So I will explain once again. So listen again. So first they are asking us to check whether our number is Armstrong or not. So what is Armstrong number? If we take this number and our sum of cubes of each digit of this number will be equals to our actual original number, then only we will tell it is as Armstrong number. Otherwise it is not Armstrong number. So sum of each digit, cube of digit. Okay, 3 cube, 7 cube, 0 cube, and we have to sum all these. Then only if our final product equals to final sum equals to our original number, then only we will say it is Armstrong. If we get another number other than our original number, means it is not Armstrong number. If you look at algorithm, we have start and we have declared our num, and we are storing our original number into original number, because we are performing operation number, right? So it will change in every operation. So but we have to retain our original value, so we are storing it in original number. Okay, and we have declared remainder, so this will be useful when we perform division operation here, and result also will be useful here. So we declared 4 variables, and we have taken user input into our num, and since we have to retain our original value, so we are storing it in original num. Okay, so initially our remainder result will be 0, because we are still didn't get into loop. So now we will check condition to go into loop. What is the condition? Our original num is 0 or not. If it is 0, then we don't have to waste our time here, because 0 is already Armstrong. 0 cube equals to 0, right? So it is Armstrong number. So if it is not 0, then we have to perform our loop. So what in our loop, what we are doing is, first we have initially given remainder to 0 value, right? So we are performing division from here. So first what we are doing is, we are dividing our 10 by modulo division 10. So here our original number, and we are doing modulo division to this number by 10. So 10 into 37 equals to 370. When we perform modulo division, we will get remainder as back. So remainder will be the value here, remainder we will get. And in second line, what will be our result? Result is result plus cube of our digit with our remainder. Okay, cube of our remainder. Here our remainder is 0, 0 cube is 0, so this will be over, and we will be storing our original number is 10. Why? Because if you look here, 370, 10, 37, 370. When we do modulo division, this will be our return number. Okay, when we do division, this will be our return number. So when we perform modulo division, we will store it in remainder. When we do division, we store it in our original number. What happening is, we have already taken last digit of this number and we perform operation on it, so we don't need it in our original number, so we are taking it out. Okay, so now our original number will be 37, and we will perform the operation same, because our number is not equals to 0. Until our number becomes 0, we have to perform operation. So 10 3 30, our remainder will be same. Still our number is not 0, so we will perform operation again, and here our number is 0, so we are getting out of loop. And here if you look here, 7 came. So in first operation our result is 0, second operation result is result plus 7 into 77, which is 0 plus 343. So here 343 will be our result. Okay, here 343 plus 3 into 3 into 3, which is 27. So here our result will be 370. Okay, so this is how our loop algorithm works, and we will do actual coding next. So wait, I will go into programming. It is. So now as we finished our theory part, now we are going to actually coding this. So first, if you look at our algorithm before, first when we start the program, we have to declare variables, right? So first I will declare 4 variables, that are num, our input, and original num to store our input, comma remainder, and result. Okay, we have seen this in our algorithm also. I have declared 4 variables, and now we have to ask our user to enter an input, right? So first we will print. So first we will print enter a number to tell our user to enter a number, not a string, right? So first we will print our user to inform please to enter a number, and then our user will enter a number, so we have to take that number. So we will use our scanf function. Okay, we will use our scanf function to take our input. Percentage d num. So we are telling our user to enter a number, and now we are taking that number and store it in our num. Okay, num variable. So after that we have to store our num into original number, right? Original num equals to num. So now we are storing our num, which is input number given by the user, into our original number, because we will perform our operations on original number, and after performing operations we will compare it again, and if they are equal we will tell it is Armstrong number, otherwise it is not Armstrong number. So that's why we are storing it in original num. So after that we will start our loop now. So while we have to give condition, right? So what is the condition? If our input is 0, that is already Armstrong number, because 0 cube is 0, right? So that's why we have to check our original num, which is our input in this case, is 0 or not. If it is 0, then we have to return it is a Armstrong number, because 0 is an Armstrong number, otherwise we will perform division operation, right? So first from division operation we will store our remainder. So for our first line will be to get our remainder from the division. So remainder equals to original num mod of division by 10. So that will be our remainder, and our result will be result equals to, we have to take each digit and cube each digit, and after that we have to sum together. But in C program we have function for that operations, right? So what is that function? Our function. So POW, this is the function for cubes. Our remainder comma 3. Okay, pow function is used to get cube of the our remainder. Okay, cube value of the remainder. So now we have our remainder and we have our cube value. So next is result after our original num. We have to take out last digit of the original number, right? Otherwise it will be same operation. So we have to take out last digit of our original num. So here we will do original num by 10, not modulo but normal division. Okay, so here we are performing division operation. modulo division operation, and we are getting our remainder, and here we are performing cube of the our remainder and storing cube value into the result, and here we are performing normal division and getting last digit, removing last digit of the number. Okay, so this will be our loop. So until when it performs? Until our original number becomes 0, otherwise it will perform loop until it is 0. Okay, so now we have finished our loop. We have to go and check, we have to check, right, if our original number is equals to result or not. So first, if result equals to our num, which is our input, then we will print percentage here slash line means new line. After we are printing this string, we are printing our result in a new line. Okay, so that's why I have given slash n and comma num, which is our input. Why we are printing our input means here, because result equals to num, which is our value equals to our input value equals to result of the sum of the cube of the digit, each digit of the number. Okay, so that's why we are printing it. Else we will copy this only. Is not, because our original value not equals to our process result. Okay, so that's why we are not printing it is not an Armstrong number. If our original value equals to sum of cube of each digit of the number, then it is Armstrong number. So now we have finished here, so we have written 0 here. Okay, now we will actually run our program. Okay, oh, spelling mistake is there, so now our program works fine. So if we click run, and it is asking us to enter a number, so we will enter 370 and click enter. So 370 is an Armstrong number, right? So it is returning 370 is an Armstrong number. If we run again and give 1 2 3 or 135, what will be? 135 is not an Armstrong number, because 1 cube 1, 3 cube 27, 5 cube 125, which is not equals to 135. It is actually more than 135, right? So that is why it is not an Armstrong number. Okay, so this is about solution whether a given number is not an Armstrong number or not. If it is Armstrong number, it means the sum of cube of each digit of the number is equal to actual value, otherwise it is not an Armstrong number. So now we have cleared our doubts, right, and we have solved our problem. So we will meet again in tomorrow's class. See you.